Okay, so I was asked to do problem number 4 on the Physics 2nd 240 exam, which says a square coil of wire 1 meter on each side has 14 loops and carries a current of 0.4 amps. It's in a magnetic field of 2 teslas, and it starts from rest in the position shown, and we're asked to calculate the maximum kinetic energy that the loop will possess in its ensuing motion. Okay, so energy is conserved here, so we can use the conservation of energy, which states that the initial kinetic energy plus initial potential equals the final kinetic energy plus the final potential. And the initial kinetic energy is just going to be 0 because it's not moving. So we can rearrange this to say the final kinetic energy equals the initial potential energy minus the final potential energy. Okay, so we'll first calculate the initial potential energy, which is equal to negative the dipole moment times the magnetic field times the angle between them, which is equal to the negative of the number of loops times the area times the magnetic field times cosine of the angle between them. And so we want to find where the dipole moment points. So we use the right hand rule, following the current as it goes around the loop. So we know that the dipole moment points in this direction. And so you want to this angle is going to equal the angle that it's displaced plus the angle that it makes with its dipole moment. So it's going to be 90 plus 25 equals 15 degrees. Okay, so if we do this, we find, let's plug in the values for them. That its initial potential energy is equal to 4.7 joules. Now we're going to do the same for the final potential energy. We know that when the dipole moment aligns with the magnetic field, that its potential energy is the lowest, which means it has its max kinetic energy. So the angle is going to be 0, and the other components are going to remain the same as they were for the initial potential energy. So this equals negative 11.2 joules. And so to get the final answer, we do the potential energy, which is 4.7, minus the final potential energy, which equals about 16 joules, which is answer choice A.